Alrighty, let's finish up this section on evaluating machine learning models. So we can do so by tackling the third and final way to evaluate a machine learning model, metric functions. So in essence, we've kind of already covered this because all of the metrics we've previously seen have their own function in Scikit-learn. Let's see what I mean by this. So using different evaluation metrics as Scikit-learn functions. 4.3, wonderful. So to do so, for classification, we had accuracy, we had precision, we had recall, we had F1. And then for regression, we had R squared, mean absolute error, and mean squared error. All right, so let's do what we always do and see the code first. And then we'll talk through it. So from Scikit-learn, import metrics, and we're going to do a full example as we always do, right? Because that's what we like to do. We like to be complete with what we're working on. Precision score, recall score. You might be able to figure out what the one is for F1 score. Oh, typed it a bit too quick. So from Scikit-learn, we'll also import our model, because what we might do is create a section here. We might go classification, evaluation, functions. Now again, this section here is just another way to do what we've done before. So ensemble, but it's good to practice. It's always good to practice. Random forest classifier, and then we want scikit-learn.model selection, import train test split, mp.randomSeed, 42, lovely, x equals heart disease dot drop. We can almost write this in our sleep now. Y equals heart disease dot target. And if you can't, that is more than okay, right? The only reason I can write this sort of out is because I've had a fair bit of practice with it, and you'll be the same too. If you're starting out now, you might be looking at all these functions, all this code, and going, holy goodness, there is so much to remember. But the beautiful thing is that it's here, it's available for you. You can run it in Jupyter Notebook, and you can practice as much as you like. So really, your only roadblock is just putting in the work and practicing learning. But don't forget, learning something new, especially machine learning, takes time. And it's not going away, so you got plenty of time. So what we're doing here, we've seen this code before. Importing some metrics, specifically accuracy score, precision score, recall score, F1 score. And we're importing a model, and we're importing train test split. We're splitting our data into X and Y. We're splitting it into train and test sets. We're instantiating a random forest classifier and fitting it to the training data. Beautiful. Writing machine learning code. And we'll make some predictions. And then we'll go Y preds, because remember, what is an evaluation metric doing? If you said comparing our model's predictions to the truth labels, to the actual labels, you would be correct. Evaluate the classifier. So now what we're going to do is we're going to take advantage of these inbuilt functions here. Right? We could use score, we could use a scoring parameter, but we've already covered those. This is using scikit-learn functions. So evaluate the classifier. What we'll do is we'll print out something nice, maybe. Classifier metrics on the test set. Wonderful. And then we're going to print out, we'll do a f string. Accuracy is going to be, we'll use the accuracy score function on y test and y preds. Wonderful. And then we're going to times that by 100, so it comes out in a nice, neat percentage, because I prefer that, or we all prefer that, than the decimals. Maybe you don't. And then we got here, we're going to go precision. Now, again, we could functionize something like this. We probably will in a future video, but just for example's sake, we'll type it out. We'll practice typing it out. That can stay like that. Oh, it needs the end of a string. There we go. Now we're going to do recall. How would you do this one? If I start you off with the f string, that's all right. We'll keep going. So recall score, y test. Remember, just comparing our predictions to the test labels, to the truth labels. And then finally, we're going to go F1. So this is something you might do, like if you're reporting to your colleague or to your boss or to your manager or something like that, or to the greater public, like how your model is doing. You might give them all these different evaluation metrics so they can start to understand, okay, the accuracy is a certain thing, but the precision is this, so they have an idea of how many false positives there are, and the recall is this, so they have an idea of how many false negatives there are, and then the F1 is kind of a combination between the precision and recall. So we'll hit Shift and Enter. Voila! Now we've taken advantage of the third method of evaluating models, and that's by directly using functions such as accuracy score, precision score, recall score, and F1 score. If we come up here, the documentation, this is a metric function, right? Classification metrics. Here we go. There's a whole bunch more there if you want to check them out. But these are some of the main ones that we've covered, and the principle is still the exact same for the rest of them. And so if we come in here, we're going to do regression evaluation functions. Turn that into Markdown. So same thing again. You could almost do this yourself, I reckon. And if not, type it out. But how would you go about it? If we look at our classification evaluation functions, what you might do is from Scikit-learn.metrics, import some regression functions, then import the regression model, then import this, train, test, split, create the data, split it into training and test, instantiate your regression model, make some predictions, and then evaluate them. But this time, instead of evaluating a classifier, you're evaluating the regression model using regression metrics. But just for completeness, let's type it out again. Metrics import R2 score. Wonderful. Mean absolute error. Now we've seen these before. Mean absolute error. Mean squared error. Beautiful. Scikit-learn.ensemble. Import random forest regressor. So this is the kind of workflow you might do for your own problems, right? If you're working on a regression problem, you might have some sort of import statement up the top of your notebook like this. Import train test split. In our case, we've already got our data in a data frame. You may have some more lines of code getting your data to a proper data frame. Oh, we almost forgot. MP random seed. So that you actually don't need a random seed. I just like to have one, and you'll see them all over the place, just so if you run the results the same as what someone else was getting. Target axis equals 1. Y equals Boston DF. Target. Beautiful. So, and another reason, the random seed, right? So if I ran these cells, and then you took this notebook as the resource for the course, and then you wanted to compare your results to mine, without the random seed, they'd probably be different because all of the randomness in this notebook, such as train, test, split, randomly splitting our data into training and test sets, would use different samples for each. And so we'd get different numbers, and that would cause confusion, which is not what we're about, right? If we're all about communicating what we're finding. So we're instantiating a model here. So random forest regressor. Wonderful. I'm going to go model.fit. We're going to X train, Y train. Beautiful. Make predictions using our regression model. Model.predict X test. Yes, yes, yes. And now evaluate the regression model. So we're going to go here, print regression model metrics on the test set. Again, you could functionize this to pass it your regression model as well as some metrics, but we're just going to write it out here just for good practice. R2 score, Y test, Y preds. Wonderful. Then we just need to end the string. We can do the same for mean absolute error. So MAE equals mean. We'll tab complete that one. Of course we will. Y preds. Wonderful. And then we go print F MSE mean squared error. Comparing it, predictions to the actual labels. Finish it off with a string. And boom. Oh, we got an error. Of course we did. And this is going to give us a warning because our n estimators is not equal to 100. And what is our other error? Found input variables with inconsistent number of samples. 102. What has happened here? 102 y test y preds versus 61. Well, you know what it was happening? It's 61 is the number of... here we go. There we go. You know how I knew that? It's because if we go up here, and if our classification problem, if we go len y preds before we instantiate our regression problem, it's 61. So because we didn't set y preds here, right, previously, this was just this. It was using y preds from above. That's where I got caught out from using the same variable names throughout the notebook, right? Ideally, we'd have different variable names for our classification and regression problems, but just to illustrate purposes, this is usually called y preds or something of the like. And there we go, regression model metrics on the test set. Now, we've seen similar metrics before. What can we do now? Well, we've covered a whole bunch, right? And the reason being is because evaluating a machine learning model is paramount, right? It's one thing to train one, but then again, there's nothing worse than training a machine learning model and optimizing it for the wrong evaluation metric. So keep the metrics and evaluation methods we've gone through when training your future models. Make sure you keep them in mind, go through them, and have a little read here. This is probably the most important section that you'll read of the entire Scikit-learn documentation. But after you've done that, you'll naturally probably start to ask, is that how do we improve these numbers? How do we make them better? They're kind of stagnant. We've been using a random seed and we've been seeing just the same numbers for accuracy, precision, recall, and F1 over and over. And same with R squared, MAE, and MSE. So in the next section, that's what we're going to cover. So if we look back our list, what we're covering, number 5, we're up to improving a model. All right, so take a little break, have a look at the Scikit-learn documentation for metrics and scorings, quantifying the quality of predictions. You can find it by just going to this URL here or searching Scikit-learn evaluator model. But otherwise, get ready for the next section. We're going to see how to improve our models.